Today, we are going to discuss one interesting topic in the context of philosophy of artificial intelligence. Okay, our topic is this. What is artificial intelligence and how does it achieve its task? How can one answer to this question? Artificial intelligence, AI, can be broadly defined as the field of study and practice that seeks to create machines capable of performing tasks that would normally require human intelligence, such as reasoning, learning, perception, and decision making. The term artificial intelligence was first coined by John McCarthy in 1956 at the Dartmouth Conference, which is often considered the birthplace of AI as a scientific discipline. McCarthy envisioned AI as the science and engineering of making intelligent machines, emphasizing the creation of systems capable of flexible problem solving and symbolic reasoning. In McCarthy's conceptualization, intelligence was not a mysterious or metaphysical property, but rather a computational process that could, in principle, be formalized and implemented on machines. He believed that intelligence could be represented through logical structures and symbol manipulation. This led to the symbolic, or good old-fashioned AI approach, which viewed the mind as a system that manipulates abstract symbol according to formal rules. McCarthy's early programs, such as Advisor Taker, aimed to model reasoning as a logical process, an attempt to simulate human thought using formal logic. Marvin Minsky, another founding figure of AI, shared this computational and representational perspective, but added a deeper psychological and philosophical dimension. Minsky viewed the mind as a complex set of interacting subsystems, each responsible for specific cognitive functions. In his later work, The Society of Mind, which was published in 1986, Minsky proposed that intelligence emerges from the cooperation of many simple, non-intelligent agents. This idea prefigured the notion of emergent intelligence in modern AI, where complex cognitive behavior arises from simple algorithmic interactions. AI achieves its tasks through various computational architectures designed to approximate, simulate, or extend cognitive functions. In the classical area of AI, in the 1915s up to the 1918s, systems primarily relied on symbolic reasoning, using explicit representations of knowledge and rule-based inference engines. However, with the rise of connectionism and the later machine learning, particularly deep learning, AI began to learn patterns directly from data instead of relying on pre-programmed symbolic rules. Neural networks inspired by the structure of human brain perform tasks such as image recognition, language processing, and strategic planning by adjusting the strength of connections between artificial neurons based on experience. From a philosophical perspective, AI's ability to achieve its tasks raises fundamental questions about the nature of understanding and intelligence. If a machine can perform tasks that appear intelligent, does it truly understand what it is doing? Or is it merely manipulating symbols without comprehension? This tension was famously explored by John Searle's famous Chinese room argument in 1980, which challenged the assumption that computational processes alone could generate genuine understanding. Yet McCarthy and Minsky both maintained that understanding could, in principle, emerge from the right kind of computational architecture, suggesting that intelligence is substrate independent. It can arise in silicon as well as in biological neurons, provided the structure of information processing is sufficiently complex. Thus, AI achieves its tasks by formalizing elements of human cognition, perception, reasoning, and learning into computational models, whether through symbolic logic, statistical learning, and neural computation. AI functions as the extension of the mind's representational and inferential capacities. This foundation makes it a natural partner for emerging technologies such as brain computer interfaces, where the boundaries between human cognition and artificial computational are becoming increasingly blurred. Okay, that's all for today's discussion. Thank you for watching. If you have got any questions, you can address them in the section of commentaries. Thank you for watching again.